This resource is the second of a two-part series that considers graphing quadratic functions, which are called parabolas. Part 1 considers the methods for graphing parabolas. We look at graphing using a table of values with an example provided. We also consider various features of the parabola. We define how to use these features to form the parabola. Part 2 of the series looks more closely at using the features to create the graph of a parabola. We define how to find the values for the features based on the equation of the quadratic. We then work through two examples. In the first part of this series, we discovered a method for graphing parabolas using their features. Find the axis of symmetry. Find the coordinates of the vertex. Find the y-intercept. Find another point on the graph. Reflect the points we found over the axis of symmetry. Connect the points and label our graph. How exactly do we find these points? Each of the features of the parabola can be found using the general form of the equation. Y equals ax squared plus bx plus c. The axis of symmetry is a vertical line, so its equation will have the form x equals something. That something is found by dividing the opposite of the b, the coefficient of the x term, by 2 times a, the coefficient of the squared term. The vertex is actually on the axis of symmetry. To find the coordinates, find the function value for the x value from the axis. The y-intercept is where the graph crosses the y-axis. Formally, this means we plug 0 into the equation and solve. This means that all the terms that include the x are eliminated. So the y-intercept is simply the value for c in the general formula. Let's work through an example. Suppose we want to graph the parabola for y equals x squared minus 2x minus 3. First, we want to find the axis of symmetry. We have x equals the opposite of negative 2 divided by 2 times 1. Completing the calculations, we find the axis to be x equals 1. Draw the axis on the graph. Now we want to find the coordinates for the vertex. To do so, we plug the one we just found for x into the equation. This gives us a y value of negative 4. Plot the point for the vertex. Now we find our y-intercept. This is just the constant at the end of the equation, so our y-intercept is negative 3. Plot the point for the y-intercept. Now we want to find another point. We pick 3 as a value for x to plug in. Plugging in, we find the corresponding y value to be 0. Our parabola contains the point 3, 0. We plot that point. We reflect any point we have over the axis of symmetry. Connect the points and label the graph. Let's look at one more example. Suppose this time we want to graph the parabola for y equals x squared minus 4x. To find the axis of symmetry, x equals the opposite of negative 4 divided by 2 times 1. Therefore, the axis of symmetry is the line x equals 2. Graph the axis of symmetry. Plug the x equals 2 into the equation to find the coordinates of the vertex. We find that the y value for the vertex is negative 4. We plot the vertex at the point 2, negative 4. Because there is no constant term in our equation, the y-intercept is 0. which we plot. We need to find another point. We choose 1 for an x value to plug in. After plugging in, we find the corresponding y value to be -3. Plot the point 1, -3. Reflect the points over the axis of symmetry. Connect and label our parabola, and we are all done.